we're going to go ahead and prepare this element to go in so that we don't have any problems once we get this one out. Sometimes if the heater is very old or there's not a water softener in the system, there's a potential for high amounts of lime. There are cases where the element will not come out, and you have to sawzall it off. This is an 1.5 inch socket that'll fit this element perfect. We're going to get it on there, start to loosen it. Once I feel safe that I can turn it with my hand, then I'll switch over to doing that. This is something you typically want to do pretty quick. Some of them will spit a bunch of water, then they start to gulp. It's loose enough to pull out by hand. That was fairly slow considering, but it'll work. Sometimes when you pull your old elements out, the rubber won't come with it, so you'll want to make sure that the rubber did come with it. This element looks like it's in good shape. It does have lime buildup on it, but just like the testing proved to be positive, so it didn't need pulled, but we did it anyway. This thermostat is the one that's popping. Typically that'll only happen when there's a problem with the elements or a faulty thermostat. Being that this one is popping, we're going to go ahead and pull it and replace it. I always put my wires to the side so I know where they hook up. If you have issues and forget which one went where, you should have a wire diagram inside your new thermostat package. This particular water heater is 220, so I could flip the red and the black on the top. Those could be switched, but those are the only ones you really want to flip around and switch. There's typically always 2 wires that go into screw number 4. And typically number, I guess, 3 and 5, or no, these 2 on the side. These are always jumped. So we've got the screws off. You can use a screwdriver or anything, you pull out on these gently, lift it up. The only thing I typically see go wrong with these thermostats is this bottom will snap inward, and there's no good way at all to reset that one. This top one, if it snaps inward, you've got your reset button on the front. So if it pops like that, it's inward, you just reset it. So if that one does, there's no way to reset it. We've got A.O. Smith thermostat we're going to put back. It's slightly different, but it's the same concept. Our temperature gauge is on the bottom versus up there. It still has the jumper on this side like this one. It's got the screw at the bottom for our element. It's got the 3 on this side, and then of course the 1 above the jumper. So this one will be a good universal to put in the Kenmore. Kenmore water heaters are made by A.O. Smith anyway. The other thing you want to make sure is that your thermostat is up against the tank. If it's not against the tank, then it will not work. It'll overheat and then shut off. So you don't want to bend this bracket out too much where you're not going to get a good reading. I'm going to go ahead and use the screwdriver instead of the screw gun so I don't have no issues. Sometimes on these screws, when you're tightening them down, it'll push the wire out. If you use the bottom, it's going to push the wire out because I'm screwing it clockwise. So I'm going to use the top so that as it's tightening down, it can push the wire into place. We're on this side, so we're still doing clockwise, but we're going to have to go on the bottom on this side or it's going to push it out. This one is the one that has 2 wires. Sometimes it can be a little tricky, but no big deal. If your thermostat didn't come with a wiring diagram, you can find them all over the internet, or if you type in Google search the type of water heater you have, you should be able to find a PDF file or some sort on the manufacturer's website. Put that in the bottom so it don't push out on me. Okay, and that was rebuilding the upper thermostat and upper element. The bottom is basically the same. You could potentially get more water because you're messing with the bottom element. It is testing good as well. But because of the age, we're going to swap it. And not to mention we're putting in new thermostats, which is going to make this work like it should. So we don't want no issues. So we're just going to eliminate any potential problems by replacing it. These things are always better to get off. A lot of times they break on you. They're there to protect the screws so you don't get zapped. Lift up on that. Try out. Obviously, I turned the power off the breaker box before I did any of this, and then tested it with the electric tester. 220 will hurt very bad. It can potentially kill you. So make sure your breakers are off before you attempt any of this. Same thing here. We're going to loosen it up with the chain locks because I don't know where my ratchet is or breaker bar. I don't suggest, if you do use a ratchet or breaker bar, cranking this element down as hard as you can, because you will fight getting it out. This one looks like the rubber's coming out as well. As long as nobody turned on any faucets, it looks like it's spraying a little bit. So we're going to go ahead and push it back in. Let's let it sit for a second. We'll go ahead and get some water out of this valve here to make sure we've got all of it. If somebody opened the faucet upstairs, it will it'll spray out fast, and we do not want that. Okay. So that seems to be good there. Some of these elements are S-shaped. This one's green, so it will be. The sand hole. Oh, normally the green ones are. It's got lime buildup on it as well, but it appears to be good. There's no breaks in it. When you're hooking your wires up to your element, it don't matter which side goes on which. It'll do what it's supposed to do, no matter if you flip the wires or not. You always want to get your wires tucked up out of the way so they can't get hot, warm, pinched. You know, obviously don't want them touching over here or anything. I prefer having the wire bent in a circle like that. Normally I'll put the screw on there and use a needle nose to grab the straight wire and just twist so it's in a circular shape. They seem to stay on and grab a little better, get a better connection. If these wires have any kind of green or anything on them, then you're going to have to either cut you a new piece, remove the insulation off of it, cut a new exposed more clean wire, or you can use a sandpaper to clean them up. We'll get this ground wire out of our way, that stuff out of our way, because we're going to have to put these back in. Only difference between this one and the one I took out is the old one had the extension for thermostatic control, and it came through here and then had a knob so you can change the temperature easily. I don't have any of them, but it'll still serve the same purpose. If you wanted to change the temperature on this one, it's right there where that flathead screws at. 125 is a perfect setting for the temperature. It should be sufficient. Normally it's not your size of your heater or how many people you have in the home as much as it is in what order do you do showers, how hot is the shower, and how long is the shower. Obviously the bigger the heater, the more hot water, but you can have a 40-gallon cranked to the max, have it 160 degrees, and it lasts just as long as an 80-gallon does, set at 100 degrees. Most important thing once you get it completely rebuilt is there's potential air inside here, and if your elements are not submerged in water, then you will dry fire and it will not work properly. So we're going to go to a faucet, all the faucets in the home, turn them on until all the air is going out of the line. Then we know it's safe to turn our water heater back on. I tend to put all my covers back on so I'm not at risk for being shocked. And then screw on our covers. Then turn the breaker on. So we'll go bleed the air out of the system, put our covers back on, flip the breaker on. 80-gallon water heater filled with cold water will take every bit of an hour and a half to get enough to take a good shower.